Okay, blank, blank. Only thing I might do here is this. Okay. No, that's not what I wanted. Oh well, hopefully it doesn't mess anything up. Is that gonna go away? Nope. Okay, it's just not gonna go away then. Where's my chart? Did that work? Apparently not today. Okay. So, where are we? Determine if the following are linear, are linear data sets or not. If not, say why. If it is, find the equation for P as a function of Q. So we want to essentially find, well, the way I do it is our little, find your change in X's and changes in Y's. So our X's or our P values here are changing by 4, 2, and 1. Right? Brain. Okay. My arithmetic is not on par yet. And then 4, 4, and 4. But 4 over 4 is not the same as 4 over 2, is not the same as 4 over 1. So this would be not linear. Slopes, not, I'll say equal, consistent, constant, whatever floats your boat. Did I do something stupid? That's not by 4. I really didn't think it was 4. That should be a 2 in the first one. I knew that sounded weird in my brain. They're still not constant. The first 2 are, but the third one isn't. Thanks. Yeah, no, that's my bad. So the first 2 are constant. They're both equal to 2, but the third one's equal to 4. I knew that sounded weird. I've done this 3 times, and I was like, I didn't think that was... Anyway, it's been a long week, guys. All right. So the next one, 2, 3, and 1, and then 4, 6, and 2. But again, we want to find our, well, no, I'm going to keep doing it this way, and then I'm going to ramble. If I look at change in Q over change in P, which is usually the way we go about looking at these, I would have 4 over 2, 6 over 3, and 2 over 1, which all reduce down to 2. So that means that is linear. Now, I was a little bit tricky here because I then asked for P as a function of Q, which means that this slope is not the slope that we need to use. So I want P as a function of Q, which means that the P values would act as my Y's. So this change in whatever that I need would actually be change in P over change in Q. And you might ask me, well, what the heck? All we did was always do the bottom one over the top one. When it comes to finding linear versus nonlinear, it doesn't matter, okay? I could have technically looked at 2 over 4, 3 over 6, 1 over 2, and still would have seen that they were all constant and called it a day, okay? So it doesn't matter really which format you use for just figuring out if it's linear or nonlinear. You can kind of use whichever one floats your boat. And I'm just used to using change in Y over change in X because that's just the way I default to, I guess. But here, since we now want to actually find the equation, we then have to go kind of back and make sure that we were using the right format, if you will. So hopefully that makes sense as to why the slope we just found isn't the slope that we want. So the slope that I would want, so let me kind of come over to the side, if my computer will act the way I want it to. So I need change in P over change in Q for my slope. So again, I can if you want to, you can just pick 2 points and find the slope between them that way if that helps you out. But it's going to turn out to be either the 4/2, 3/6, or 1/2. Does anyone want me to do that in more detail than what I just said? No? Okay, cool. Or maybe. Yes? Okay. So I need a change in P over change in Q. Let me just pick some points that make me happier. I'm going to pick the 2 in the middle just because those are the 2 that I'm choosing to pick. So if I need to find the slope between them, so I need the change in P over change in Q. So the P values are the 3 and the 6. So we had 6 minus 3, and therefore 8 minus 2. So we'd have 3/6. So our slope would be 1/2 that we actually want to use. Does that help? Hopefully. So the slope that we actually want to use here is 1/2. So now we need to go ahead and find the P equals MQ plus B. So pick whichever point makes you happier. I'm going to use the 6, 8 because they're both nice even numbers and I like that. So the P value is 6, slope is 1/2. My chosen Q would be 8 plus B. So B is 2. And then, of course, you need to actually just write the actual equation out. So P equals 1/2 Q plus 2. So I know that one I threw a little trick in there, kind of last minute. But again, just for linear, nonlinear, doesn't matter which form you take. You can take whichever one makes you happier because you're just looking for constant slope. You don't care which slope you're talking about. But if you're then asked to find the equation, make sure you're in the right order. All right. Then for the second one, seems like we're good. So find the desired, something got cut out. Find the desired average rates of change. So between 1 and 9. So again, remember average rates of change are essentially a slope. Yep.
Okay, back to one. Okay, we just did. So like it doesn't matter like which one you do. Like you were to pick like for P1 and 3, or say like
So like for this step right here, if I had chosen 3 and 2 or 1 and -2, or if I'd chosen a different point,
yeah,
you would always get B equals 2 in either way. So you get to pick whichever point makes you happier because they all are going to give you B equals 2. So like, let me take the 7 and the 10. 10 equals, oh, this is going to be, nope, I put it in the wrong order. That's why. P is 7, so P equals MQ plus B. 7 equals 5 plus B. B equals 2. If you use them in the right order, which I was about to not do, it doesn't matter what point you take. Why is this not scrolling right? All right, average rate of change between 1 and 9. So remember, that's essentially a slope. So we can calculate it with our 15 minus 7 over 1 minus 9, which is 8 over -8, or -8 over +8 if you would flip-flop the numbers around. So that'll reduce to -1. And then between 3 and 5, 10 minus 3 over 3 minus 5, 7 over -2. Yeah, so the 15 minus 7. So in that one, we're looking for the average rate of change between 1 and 9. So I've circled those 2 now. And so our average rate of change is always our change in y over change in x. Usually it's written like this for average rate of change. But you can think about it as the same thing as slope, y2 minus y1, x2 minus x1. Yeah, sorry. Yeah, I guess it kind of got off to the side a little bit. What? Well, like here, I don't give you units, so no. If it had units, If it was a question that was written by me and the instructions didn't explicitly say state units, I wouldn't take points off. If my directions did say and state units, then you'd want units. The question teams was, do we want units on these average rate of changes? But I will say, if there are units in the problem, it's always just kind of good practice to just tack them on anyway. But specifically in terms of like points on quizzes or tests, double check my instructions. Pretty much, I always try to pack my instructions with what I'm exactly looking for. And if I don't tell you I'm looking exactly for that thing, then I can't fault you for not having it. All right. So yeah, sorry, Savannah, we were using that table, kind of got off to the side of the question. Sorry about that. Questions, concerns on the warm-up? All right, if you're comfortable with that, you should be comfortable with the quiz later. So, notes. We finish at 4:05, so I gotta shut up at 3:50. All right. So, notes. Yeah. So we started talking about cost, revenue, and profit. And where did we end? I think I wanted to go over this one like again. Specifically, I think I wanted to go over part 2 again because I kind of rushed through it. So let me just erase all this hoopla and we're going to talk about it again. Just to make sure it's all in there. So part A, we got through part 1. I think was okay. Maybe I'll talk about it really quick. So to remind us, we're talking about this radio factory. And the radio factory was also from the previous example. So we had this cost function of 7Q plus 24,000. And then we were asked, well, if they sell them at $15, what's the revenue and profit? So the thing we need to definitely make sure we're remembering is that revenue equals price times quantity. So we used that to find our revenue function of 15Q. And then we found our profit function by taking the revenue minus the cost. Always put the cost in parentheses so you remember to distribute the negative. So 15Q minus 7Q gave us 8Q, and then we have minus 24,000. And then part 2, we were asked to find the break-even point. So remember the break-even point we have 2 definitions for, either profit equals 0 or revenue equals cost. Maybe I shouldn't say they're different definitions. They come from the same thing. So here, since we had our profit function, we went ahead and just set that equal to 0. And we got Q equals 3,000. Now, the thing that I had started writing the other day was that the break-even point it's made up of 2 different things. It's got the break-even quantity, which is found by setting that equal to 0 or revenue equal to cost. So that's like what we just found, this Q equals 3,000. That's the break-even quantity. But then there's also the break-even price as well. And the break-even price, you do have to be slightly careful with. What you want to do from there is you're going to plug Q into revenue or cost, not profit. If you plug it into profit, you're just going to get 0. And while technically, yes, that is a good thing to recognize that it breaks even when profit is 0. But when it asks for the price associated with it, it's talking about the price for the revenue or the cost. And it doesn't matter which one of those 2 you plug it into because they should have been equal to begin with. That's kind of the point. So you get to choose. 90% of the time, I'll choose revenue because it's usually the easier of the 2 functions. But whichever one floats your boat. Now, with Wiley, Wiley sometimes just wants the quantity, and it'll usually just ask for Q equals, or it'll say quantity and ask you about nothing else. Sometimes it will then ask you about the price. So Wiley can get a little back and forth on whether they want one or both. I always want both. And I will usually always be very careful in my instructions to either bold the word point or specifically say break-even price and break-even quantity. But I always want both. Anyway, so we found the break-even quantity already the other day. Yeah, so super quick side note. So we had found the break-even quantity from setting profit equal to 0. If I had set revenue equal to cost and solved, I still would have gotten 3,000. So you kind of get to pick which way you want to go. Do you want to set profit equal to 0, or do you want to set revenue equal to cost? That was for Jamie. So now I want to find the break-even price. So again, I personally usually plug it into revenue because you just got to multiply it by one thing and then you're done. So I would just find revenue of 3,000. So that would be 15 times 3,000. One thing I'll say really quick, sometimes people are freaked out by function notation. So, you know, just know that Q can take on any value, and it's just saying that that's what you're plugging in. Some people seem to think that I'm then multiplying R by 3,000, and they do weird things, and it makes me sad. It's just function notation saying that you're plugging 3,000 into that function. So don't make me sad if you can help it. Anyway, so that is, what is that, 45,000? So that would be your break-even price. So quantity would be in, units, like literally the word units, unless they give you like, if you're specifically given a context like chocolate bars, or, well, in this case we had radios. So 30,000 radios and $45,000. Okay. Anyway, so the last two things we wanted to do here was to sketch first the revenue and cost functions and label the break-even point, and then sketch the profit function and label the break-even point. So part 3, we want to sketch. And again, when I say sketch, I mean sketch. So we want to sketch the cost function. So that's the 7Q plus 24,000. Well, we kind of already sketched that the other day, didn't we? And it was, high up on the y-axis. Very much not very much not a steep, excuse you. What is happening? Oh, I love virtual learning. I love it so much. There we go. So this would be our C of Q. Excuse you, Lord Almighty. Because again, so that was where to go. Let me put it over here so that it's on the screen. And then I want to graph 15Q. Well, that has a y-intercept of 0, so it starts all the way down here. Most revenue functions do. Linear revenue functions, maybe I should say. But it's got a steeper slope. It's still not an obnoxiously steep slope, but because it's so much larger than 7, I'm going to make it look much steeper. So I'm going to go ahead and draw it like that. That's not very straight. Let me make that a little more straight. Ooh, that's a little better. So this would be R of Q. Now, I mean, I guess someone on Teams can answer, but I'm kind of saying this more for the people in class, but whatever floats your boat, if you want to unmute yourself. Where on that graph is the break-even point? Where they intersect. Right, so right here is the break-even point. Because of the fact that one of the ways you can get it is when revenue equals cost. What up? Yeah, let me. So this one was revenue. and then the other one was cost. So the one that's higher up to begin with is C of Q, and then the one that starts at the origin is revenue. And so then I want to, instead of sketching revenue and cost, I want to sketch profit for part 4. Well, profit has a y-intercept of negative 24,000. So I'm going to start somewhere down here. And since it's the only thing I'm going to sketch, I can kind of make it kind of as steep as I want, really. But it's 8, so, let's make it, let's at least get it to cross the x-axis. Let me say that. Where on that graph is the break-even point? Where it crosses the x-axis, which is why I wanted to get it on there. So this here is the break-even point. So I do want to say, I know it's somewhat unfortunate that the break-even point does show up in profit and it does have a price of 0. But just know that when we say break-even price, we want the non-zero price. What up?
Can I ask a question? For like, I know you're going back to like part 2, like a break-even point. Is there like, out of the numbers that we got, like 3,000 and 45,000, is there one that we need to write in order? Is it like an actual point that we need to write it as, or one like an X value and one like a Y value?
So the question, teams, that I'm going to answer first, and then I'll get to your ones in chat, was, so we have these 2 points, Q 3,000, well, 2 values, Q equals 3,000, and then the price is $45,000. Is there a certain order you should write them in? Technically, 90% of the time, since the functions are C of Q, R of Q, pi of Q, the Q would be an X value. So it would be 3,000 comma 45,000, 90% of the time. Sometimes they go and switch the variables on you. So sometimes it does flip-flop, but 90% of the time it's Q, it's quantity comma price if you want to consider it as a point. The way you'll be able to see if it's the opposite is you'll start seeing, I don't have any space anywhere, R of P and C of P and pi of P instead of Q. And that's when you know that now the P value is acting as the X. This does not come up as often as R of Q. R of Q is used 90% of the time, but that can happen. So yeah, excuse you, erase. How do you know what they look like on the graph? Okay, so the main thing, since I'm just sketching, so I'm not trying to make it super perfect, I'm looking at 2 things. I'm looking at the y-intercept, and I'm looking at the slope. So say for my my profit function, because that's the other question as well. So my profit function came from part 2. Nope, came from part 1. What am I talking about? Came from part 1. So we found our profit function by doing, revenue minus cost. So our revenue, I keep getting my words backwards. The profit function we found was 8Q minus 24,000. So what I'm doing when I'm sketching them is I'm saying, okay, well, my B value, my y-intercept, was negative 24,000. Well, I'm not trying to make this look perfect, so let me just grab a, semi-far away point from the origin below the x-axis. So that's why I started right here. And then I gotta say, okay, well, the M, that's the slope. That was 8 in this case. So that's not obnoxiously steep. It is kind of, not very steep compared to 24,000, but this is the only line I'm drawing on there. Let me draw just, however steep I want, really. When it came to part 3 for C of Q, we have a slope of 7. That's not very steep, so I made the first line, not very steep at all. Whereas comparing that to the slope of R of Q, our revenue slope was 15, which is much steeper than 7. So I wanted to make the revenue function steeper than my cost. Again, I'm sketching it, so I don't need to make it perfect. It just needs to look steeper than the cost function I just drew. I know that's a little wishy-washy because it's a sketch, but does that make sense, Rihanna? So I'm just looking at the function, pulling off the y-intercept and the slope. My main thing is to start with a semi-correct y-intercept and then just use my slope to, if you're only sketching one thing, you can kind of make it however much you want because it's kind of up to you. But once you start getting more than one on there, you have to really make sure that the steeper one looks steeper than the less steep one. Does that make any sense? Sometimes I just feel like my words sound like babbling. Okay, cool. What's next? 324. Okay, cool. So this little note is kind of getting lost in everything I just wrote. So we had marginal cost. Remember, marginal cost was the slope in linear cases, and that was the cost of making the next item. You can also talk about marginal revenue and marginal profit. How much extra money do you get from selling the next item? How much extra profit, so revenue money versus profit money, do you make from getting the next thing? So we can say marginal whatever in terms of always all of them cost, revenue, and profit. Okay, this is a little tidbit. All right, some new definitions. We've got the supply curve. For a given item relates the quantity Q of the item that manufacturers are willing to make per unit time to the price for the item for which the item will be sold. I'm going to finish defining these and then I'm going to try to explain them in a bit more modern English. And then the demand curve relates the quantity Q of an item demanded by the consumers per unit time to the price of an item. I'm going to try these captions again. Nope. Okay. So let me try to explain that in a bit more, well, babbling, because that's what I do. The supply curve is essentially, so you run your business making your radios, and you go up to, you've decided that you don't want to make them yourself. You want to go to someone and have them make them for you. You want to go to a manufacturer. So the supply curve is essentially you walk up to the manufacturer and you say, hey, I want you to make me these radios. I'm going to be selling them for 15 bucks. And they're like, all right, cool. If you're going to sell them for 15 bucks, I'll make you 15,000 of them. And you're like, all right, well, just kidding. I actually decided I want to sell them for $10. And then they're like, okay, well, if you're only selling them for $10, you know what? It's not worth my time. I'm only going to make you 10,000 of them. So the supply is essentially telling you, if this is the price, how many is the manufacturer willing to make for you? And sometimes, so you have to be careful when you're given these. Sometimes the price is the X, sometimes the quantity is the X, but it's still the same idea. As whatever point it is it's the price that you're selling them for versus how many they're going to make for you. Whereas the demand curve is essentially you go out to the people that you're going to sell your radios to and you say, hey, people, I'm going to sell these radios $15. And they're like, cool, we'll buy, 13,000 of them. And you're like, score. And you're like, wait, just kidding. They're only going to be $10. And they're like, score, we're going to buy 20,000 of them. So the demand is the price that you're selling it for compared to how many the people are going to buy. Does that make sense? So supply, how many is the manufacturer going to supply you? And demand, how many are going to be demanded by the people? So hopefully that makes sense. So let's look at these two little, we have a supply curve and a demand curve. And I want to know what the kind of interpretations of this P naught, P sub 1, and Q sub 1 are. So here we got it. So let's make sure, doesn't price go up as demand goes down? Price go up. That's usually what happens. Wait, no, aren't you right? demand usually goes down as price goes up. So that's, I think it might be part of your confusion, might be the next thing I was about to say. We need to be careful here. Like I just said, it kind of depends on what graph they're giving you as to what the X values are. Here, our X values are quantity, okay? So we're going quantity in this direction, price in this direction. Maybe, Brianna, let's just say we have a really weird situation going on here with this really weird thing, and here's our supply and demand. So who knows? You would think that if the price goes down, more people are going to buy them, but you know, maybe it's a laptop and people start thinking the cheaper it is, the worse it is, so they're not going to buy it. You know, kind of reverse psychology kind of thing. Anyway, so let's just go with these. So let's say I wanted to interpret this P naught. Well, let me think about what that is. So I don't have any actual, you know, values for price here. But if you think about it, this is telling me that Q is 0, right? Because that's the y-intercept. That's when Q is 0. So this is essentially telling me the price for which the manufacturer will make me no things. That was a bad way of saying it. The price for which the manufacturer, and Lord knows if I spelled that right, are not willing to make any items because quantity is 0. They are making me no things. I walked up to them and say, hey, I'm going to sell these radios for $4. And they're like, not worth my time. Bye. I'm like, okay. And I walk away really sad because I wanted to sell radios for $4. Does that make sense? Whereas now we go over to our demand curve and we've got this P sub 1. So I got to be careful because I've got two things I got to write here. So we've got this P sub 1. But again, this is our y-intercept. So that's still going to mean that our quantity here is 0. But here this is demand. So this is saying I'm going to have 0 things demanded if the price is whatever P sub 1 is. So that's essentially, I go out to the people and I say, these radios are going to cost $500. And they're like, no. I'm like, okay, sorry. So this is essentially the price for which customers, I'll say consumers, that's usually the word used. Consumers will buy no products. And actually, no, Rihanna, this is exactly what we think it is. As price goes up, as you go farther up in the y-axis, demand is smaller. So small demand meant high price. So this is exactly what we're thinking it was. Anyway. So then what about this Q sub 1? Well, this is when, you know, your price is 0, right? Because that's the x-intercept, if you will. So this is saying when, now this might not make logical sense if you think about it, but it also kind of does. This is saying that's how many you're going to sell if it's free, you know? So maybe some people don't want it anyway. But so that's going to be the quantity. I'm going to say demanded instead of sold because they're free. When the product is free. So when the price is 0, when you go to the populace and you say, hey, I'm giving away free radios, and some people are like, cool, I want one, and other people are like, I don't care about radios. I'm losing my voice. I'm starting to exclude. Does that make sense? Okay. Cool. Questions, concerns? Keeping an eye on chat. Seems like we're good. Okie dokie. We're not going to get the 1.5, are we? Rest in peace. All right. A movie theater sells 50 tickets a week for the price of $10 per ticket and sells $75 75 tickets when the price is $8 per ticket. Find the demand function, assuming it is linear, as a function of price. Find the revenue function for the theater. This is a somewhat common type of question, I guess, where you're essentially given this information of how much is demanded for each price point, and you need to figure out the actual function. So the first thing is, let me remind myself or point out the format that we want the function to be in. So find the demand function, assuming it's linear, as a function of price. So demand is a function of price. Now we're going to use Q for demand because it's quantity versus price. So if demand is a function of price, Q equals F of P. Demand is a function of price. Function of price, F of P, is the way you want to kind of think about it. So once I have that idea, now I'm going to go back and I'm going to find those two pieces of information that I have. So I have 50 tickets, or it's not going to highlight. We have 50 tickets at $10, and we have 75 tickets at $8. Those are the two bits of information we're told. I can change those into points. So my points are going to look like P comma Q, right? Because of the way we're setting this up. So that means my 2 points are going to be 10 comma 50. Price of $10 for 50 people to take them. And then 8 comma 75. And now we're told to assume it's linear, so now we want to find a linear equation. Well, we have 2 points, and we know how to find the equation of a line using 2 points. What's the first thing we always need? Slope! Thanks. Slope. So the first thing we need is our slope. So I always put the larger y value first, so 75 minus 50. So then the 8 must go first. So 25 over -2. So 12.5. Negative 12.5, thank you. Now that we have our slope, we go ahead and look at our y equals mx plus b, or in this case, q equals mp plus b. We get to pick whichever point makes us happier. I don't know. I guess the 1050 makes me happier. Again, it doesn't matter which one you choose. You're going to get the same answer either way, but whichever one makes you happier. Go away. So the Q is 50. M is negative 12.5. P is 10. And don't know what B is yet. So 125 plus B, negative 125. I wrote it, but I didn't say it. Add 125 to both sides. 175 equals B. So our demand function is negative 12.5 P plus 175. Now we're not done, but that was part of it. Questions, concerns on that? And that's actually a good thing. Can you use y and x instead? Quote unquote, yes, but hear me out. If it's easier for you to switch over to y and x, feel free, but at the end, your answer needs to be in terms of p and q. So you would need to change back. So you still need to recognize which one is, like, which q, does q mean y or does q mean x? But if to do the actual work, you feel better working with x's and y's, go right ahead. But your final answer should always be in terms of the variables that the question is given in. Also, 100% that for Wiley, because Wiley will just tell you you're wrong if you're using the wrong variables. You can have the quote-unquote right answer, but if you have an X instead of a P, it's going to mark it wrong. But yeah, if it's helpful for you to work in terms of X and Y for the scratch work, go right ahead. All right, but now we were asked to find the revenue. Now, I'm just going to write R, and I'm not going to put an of anything for a second. But remember, I told you, it's important to remember, that I said remember too many times, that revenue is equal to price times quantity. We have a Q right here. We have a Q right here. We're going to be able to take that demand function we just found and plug it into the revenue price times quantity hoopla, and that'll be our revenue function. It's going to be in terms of P instead of Q. I told you sometimes it happens, but that's what we're going to do. So our revenue function here is going to be P times negative 12.5 P plus 175. You should distribute that P. It's just good notation. So we would get negative 12.5 P squared plus 175 P. If you left it as the first thing, would I mark it wrong? Most likely not. And that's like a 99% sure, probably not. If I had specified, like, make sure it's as simplified as possible, but I usually don't do that. But seriously, always just read my instructions. They try to lay out exactly what I'm trying to look for in terms of an answer. But that would be our revenue function. Again, this is now revenue in terms of price, but that's fine. Questions, concerns on that? All right, so we're going to get through this one last thing. We're not going to start 1.5 today. That's sad, and so I have to talk about something before we go. But anyway, our last definition. The equilibrium point. Equilibrium. Equilibrium point. The equilibrium point is where supply and demand are equal. It's essentially like a break-even point, but for supply and demand. So, just like the break-even point, it's made up of the equilibrium quantity and equilibrium price. So it still also has 2 points. 2 parts, I should say, maybe. Yeah, that's exactly why I'm going to talk about that in just a second. Sorry, first name's cut off. It's Alexa or something like that, right? Sorry, I can't read it. So say I wanted to find the equilibrium point if demand is equal to 100 minus 2p and supply equals 3p minus 50. Set those two equations equal to each other. 100 minus 2p equals 3p minus 50. Solve. I personally always get the variables together first, so I would add 2p to both sides. I also like my variables being the one with the positive number, but whatever floats your boat. 5p minus 50. Add 50 to both sides. I'm going to come up here. You get 150 equals 5p. Divide both sides by 5. Get p is 30. But again, this is just one part of it. This is the price now. And now, so since these two things are equal at that point, the next thing is you just pick whichever one makes you happier and plug that p-value in. Because since they're equal, it shouldn't matter which one you plug it into. That's kind of the point. So I like the really demand one better. So I'm going to say 100 minus 2 times 30. So 100 minus 60 is 40. So I could say, you know, $30, 40 items would be my equilibrium point. Savvy? All right, I have a few minutes before we needed to start the quiz anyway, so I can babble. We were supposed to start 1.5 today. Obviously didn't happen. The homework that's up right now covers 1.5. Since we haven't talked about it at all, I don't want to do that to you. I need to double check if this is possible in Wiley, because I've actually never had this issue before. If I can just take them all off, I will. But I don't know if that'll just make everything explode or not. So, and I will send out an announcement on Blackboard in case anyone is not listening or just doesn't remember. Either the questions are going to disappear if it's possible. From 1.5, you'll still have the 1.4 questions you want to run through. Or if that would make everything explode, what I'm going to do is I'm just going to take the homework to be out of however many points the chapter 4 stuff is worth. And then so 1.5 will go on to next week's. So you'll still do the problems eventually. So I wouldn't even say do them for giggles because you're going to do them again next week. I mean, I guess, anyway, do whatever you want. But so either the questions will disappear or I'll just specifically, so if the 1.4 material is, I don't know the numbers, 50 points out of the 100 that the whole thing is worth, the thing would only be counted as 50 points. So that's how I'm going to deal with that. Apologies. We're a bit behind where I thought we would be. You know, doing this hybrid 2 things at once all the time is making things hard. So we'll just adjust as we go. Hopefully you're just giving me grace for that and not hating me. So that's how that's going to go. So I started the homework with stuff when I can't figure out the new thing. I have to. No. And that's what I mean by I need to figure out if I can do it without making everything explode. If me taking off those 1.5 questions would mess up the rest of it in any way, then I'm not going to do it. If there's a way where I can just make them disappear and everything you already did is still there, then I'm going to do it. But if it would make everything explode, then I'm not going to do that to you. You're not going to have to redo anything you've already done. So yeah, no, that would make y'all hate me anyway. So yeah, that's how that'll go. Again, I'll send out a thing on Blackboard and an email to just go through exactly how that's going to work. It's most likely going to end up being that I just take the points. That's probably going to be the way it goes. Anyway, y'all are like, all right, can we just take our quiz and get out of here? Can you stop babbling like a dork wand? So let's do that. So I need to stop the recording. I need to